In this problem, we will determine how many grams of sucrose is required to be added to our solvent of water to lower our vapor pressure. So the vapor pressure of pure water at this temperature is 17.5 millimeters of mercury. They want to know how many grams of sucrose you need to add to your solvent of water. Sucrose is the solute. How many grams of this solute do you need to add to this much amount of water to get the vapor pressure down? So to get it down, 2 millimeters less than 17.5 means that we want to get it to 15.5 millimeters of mercury. So the equation that we're going to use here is, remember our colligative properties. So one of the colligative properties is that the vapor pressure of the solution, which is solute plus solvent, the vapor pressure of the solution, so the vapor pressure of the solution, which is solute plus solvent, is going to equal to, this is the vapor pressure of the new solution, is going to equal to the vapor pressure by itself of the solvent, that is without anything added, totally unadulterated, times the mole fraction of the solvent. Well, they want to figure out how many grams. Let's look at the problem one more time here. How many grams of our solute sucrose do we add to 552 grams of water? So the first thing we have to discriminate, what is our solute and solvent? Water will always be the solvent. Sucrose hence will be the solute. 2 millimeters less than vapor pressure alone, of water alone. So we're looking for a vapor pressure of 2 less, right? So we're looking for a vapor pressure of 15.5 millimeters of mercury. They tell us the pressure of water at 20 degrees by itself is 17.5 millimeters of mercury. This is our moles of solvent. It's a fraction of moles divided by moles of solute plus solvent. So let's go ahead and look at the other data the problem gives us here. 552 grams of water. Let's go ahead and convert that to moles of water, utilizing the molecular weight of water. So we're starting out with 552 grams of water, and doing that on my calculator, I'm getting about 30.62 moles of water. The moles of solute here is something that we're not given, right? So we're not given anything with regards to the moles of solute. We're given the temperature, which is only important because vapor pressure is quoted at a specific temperature, right? So let's go ahead and figure the moles of our solute. So pressure here, moles of our solvent is here and here. So we can utilize that, plugging numbers in to solve for this. So let's put our numbers in here. Moles of solute plus moles of solvent, the total here. So this is actually going to be 30.62 moles. So let's divide by 17.5 on both sides of the equation. So 15.5 millimeters of mercury divided by 17.5 millimeters of mercury has to equal 30.62 moles. This is going to be our moles of water. Remember, moles of our solvent divided by moles of solute. That's something we're trying to solve for here, plus 30.62 moles of our water. So on my calculator, I'm getting this fraction to be about 0.886, doing that calculation. So it's a fraction, so it's unitless, the units cancel. And that's going to equal to 30.62 divided by, I'm just going to call this x plus 30.62. So really the problem is how to solve for x. I'm going to multiply both sides of the equation by x plus 30.62. So moving it back up here. So letting x equaling our moles of solute, I'm going to get 0.886 times x plus 30.62. I'm going to add my units later. Distributing this out, 0.886x plus, what's 0.886 times 30.62? I'll do that on my calculator really quickly here. 27.129 equals 30.62. This is really an algebra problem now. So I'm just going to go ahead and quickly solve for x. It's going to be 30.62 minus 27.129 divided by 0.886. So roughly about 3.94. Let's just put some extra digits here. 0.02 moles of this solute. Okay, the solute, and solute, by the way, here is sucrose. So it's going to take 3.9402 or so moles of sucrose to get our vapor pressure down from 17.5 to 15.5. They want it in grams. So let's just go ahead and finish off this problem by solving for this 3.9401, or let's just call it 0.2 moles. I'm just putting in some extra numbers here, and our final answer will get it to 3 sig figs. So moles of C12H22O11. And for every 1 mole of this sucrose, which is C12H22O11, there's this many grams. 1350 or so grams, 1,350 grams, or 1349 grams of sucrose. If you want it to 3 sig figs, we can do 1.35 times 10 to the third grams, but 1349 grams should be suffice. So we